Okay, I'm going to demonstrate how to bench test the boards. Okay. Now, right now, I have the top board here and the bottom board, and they're connected with a fiber optic. And let's see, got a bad ground here. There. Oh boy. Channel 1, edge, trigger mode, alternate, single, alternate. Seems to be a loose connection. There was a loose connection here. This is your power control. I just have a little potentiometer here, like 1K, 1000 ohms, which we can use to simulate the power. I think it's loose. There. Then I have a switch over here. Turn it off. You notice, see these two switches, two LEDs here. Now it's off, and I flip the switch, and it's on. Now this is a newer board, so the older boards don't have these LEDs. And the way the system works is you get a signal from this connector here, measures current, and it goes to this chip. And the signal produces a 0 to 5 volt signal, and also the potentiometer produces a 0 to 5 signal. Okay, and they're compared, and that's how they regulate. Now, not everyone has an oscilloscope, so I'll just show you a few things. Now, obviously, we're not heating now, but I'm trying to explain how the system works. So we have a voltmeter. We set it for DC. And I put the black wire on the ground. This is the ground. So the potentiometer outputs, right now I got 2.6 volts. And it outputs to pin number 2, 2.5. Now when you want full power, at pin number 2, right here, that should show around 5 volts, okay? And pin number 3 should be almost 0. Now if you don't have enough water pressure, pin number 3 will receive a signal from the water pressure switch, and it will go higher than what you see here. And if it goes much above 0, you won't heat. So you want that pin number 3 to be 0. Same with pin number 16, right here. Pin 16 should go to 0. Now watch what happens when I turn the heating off. I should have gone up. Anyway, pin 16 should go to 0. Off. Delay. On. Okay. I had this the delay switch, I had it in off position. It should be in the on position. So pin 16, let me see if I can. Okay, pin 16 when we're not heating is at about 3.3 volts. And then when I go to heat, it starts going down. And you can see over here. And it should go to 0 or close to 0, and that'll give you full power. Alright, and I turn the power off, and it goes right back up. And you can see by the display, nothing. And you can see how that came up slowly. That's called the soft start. And the soft start is controlled by this potentiometer here, the blue one. Now what I'm going to show you, we have the fiber optic going to the bottom board. Let's zoom in on this. Get a little closer here. Well, I have to be back enough to capture everything. So right now we're trying to heat, and as you can see, we have red light in the LED. And over here I put a little connector on, and that connector tells me what's happening with the IGBT. Now, IGBT is mounted to this board. Alright? So let's go look at the IGBT. See, right now, if you look at the scope, we're only looking at the top board. This is the signal generated by this chip. Now we're going to look at the result of that signal that comes over to this board. Okay? So I'm going to change. See, right now we're on channel 1. I'll turn that off. We'll go to channel 2 and turn that on. And there you are. Basically, it's the equivalent waveform, except channel 2, which is measuring the actual gates drive, is a plus 15 and a minus 8 or a minus 9. So that's what you should see if you're connected to this connector, and all the boards have that connector on it. So that's your power. And what I'll do is I'll go back to this potentiometer and I'll turn it off. There you go. I'll turn it back on, and then I'll turn the switch off, and I'll turn it back on, and it comes up nice and slow. And the reason you have this up and down is this is your on time, this is your off time. So that's how the bottom board controls power. If you want lower power, what it does is it increases the off time. You want more power, it increases the on time. That's how it regulates. So if you don't have full power, these are some things you can check. Of course, it helps to have an oscilloscope. And actually, I bought this oscilloscope in Singapore for a little over $1,000. And it's a good one. And I prefer a color, especially if you have two waveforms. Yeah, so now you can see the two waveforms are in sync. The red is the signal coming from the top board, and the yellow is the signal at the IGBT. There's another thing about these IGBTs. They're in short supply, but I have them. And there are some that are for sale in Hong Kong by brokers, but they're not good. They're they're defective. They look good, but when you test them, they don't work. So that's it. So what I'm going to do is I'm going to turn off the camera, and then we're going to switch to the middle board, and then we're going to do a demonstration of how to check the middle board. So I'll turn off the camera.